Okay, today's lesson is all about relations. So let's begin with a definition. A relation is a set of ordered pairs. Ordered pairs are something that you've studied in previous grades, and ordered pairs exactly what it sounds like, a pair of numbers or variables in a specific order, which must follow x, comma, y. So if you have a set of these, two or three or four more combined together, they form a relation. And these relations, as I've said, can be represented by a set of ordered pairs, but they can also be represented by a table or a graph or something known as a mapping. A mapping is quite simply, and there's a diagram of a map below, a mapping simply illustrates how each element of your domain, which are your x values, how each element of the domain is paired with an element in the range. The first set of numbers in your ordered pairs are always your domain. So your x values are known as your domain, and then the set of second numbers within your ordered pairs, or your y values, are always known as your range. So let's have a look what that will look like in an example. You will be given a relation that will look something like this. In this case, we have three ordered pairs. We have 1, 1, 0, 2, and 3, -2. Remember, every first number represents your x values, and every second number represents a y value. The question wants you to take this relation and represent it in three different ways: a table, a graph, and a mapping. So this example has already been completed for us, so we'll read through it together to make sure we understand it. The first one is a table, something that you've had a lot of practice with in previous grades. The left-hand column always represents the x values, or the domain. So you take the first number from each bracket, which if you look back at your relations, at your ordered pairs, they are a 1, then a 0, and then a 3. And that's exactly what's in our left-hand column here, 1, 0, 3. The second column are your y values, which is the second number in each bracket, which in this case is a 1, a 2, and a -2, which if you look back at the table is exactly what we have listed there. So simple. The second one is a graph. So to remind you on where these points came from, you look at each ordered pair one at a time. The first one is 1, 1. This means that when x is 1 on the graph, y is also 1. So even though this graph doesn't have numbers, if we just follow the grid, here is my x-axis, here is my y-axis. When x is 1, y is 1. So there is my first ordered pair represented as a point. We do that again for our second ordered pair. When x is 0, y is 2. So when x is 0, y is 2. And lastly, my third ordered pair, when x is 3, y is -2. When x is 1, 2, 3, y is -1, -2. So those three dots represent my three ordered pairs in a graph. So far we've done a table and a graph. The last one is the only one that may not be familiar to you at this stage, and that is something called a mapping. And it is simply what it said in the definition. It shows how each element of the domain, so each number of your x values, how they are paired with the corresponding element in the range, the y values. So we've taken the bracket, the ordered pair, and split it. So instead of 1, 1 in a bracket, we now have 1 with an arrow leading to its corresponding element, 1, 0 with an arrow to its corresponding element, 2, and 3 to its corresponding element, -2. Very similar in appearance to the table that we did at the beginning. So those are the three ways in which we can represent a relation. So now we're going to practice one that isn't completed, so we know exactly what's expected of us. So I'm just going to scroll down. So very similar to the first one, but this time we have to do it all ourselves. Before I do that, sorry, I didn't finish that question. I also had to refer to the domain and range. Sorry. The domain for this relation, remember, is all of the x values. There they are in a single bracket. And the range for this relation is the y values, and there they are listed in a single bracket. Okay, now let's try and do this without the answers in front of us. We're going to do one on our own. Here it is. Express the following relation. So once again, we're being given three ordered pairs: -2, -1, 3, 3, and 4, 3. We now need to represent those three ordered pairs in three manners: a table, a graph, and a mapping. So I'm going to just change the color of my pen over here, come back down. Let's begin with the graph. The first point, when x is -2, y is -1. So x is -2, y is -1. I place a point there. The second point, when x is 3, y is 3. So when x is +3, 1, 2, 3, y is also 3, 1, 2, 3. Make a point. Last one, when x is 4, y is 3. So here was x was 3, x is 4, y is 3. There is my third and final point. So my relation has now been represented as a graph. The second thing I have to do is represent that same relation in a table. So I look at each ordered pair and split it into two columns. So my first ordered pair was -2 and -1. My second ordered pair was 3 and 3. And my third ordered pair was 4 and 3. So simply split the ordered pairs into two columns. And then last but not least, the mapping. Very similar to a table, I list my domain or my set of x values in this left-hand box, -2, 3, and 4. In my right-hand box, I list my range or my y values, -1, 3, and 3. And then I simply show how the domain corresponds to the range by drawing an arrow from the left to the right. So we have now represented our relation as a graph, a table, and a mapping. The final piece of the puzzle is then to determine the domain and the range of the relation. I'm just going to give myself a little more space at the bottom here. So if you look back at your definitions, your domain is your set of x values, and your range is your set of y values. So keeping that in mind, we will simply list them within a bracket. So the domain of the relation we have just completed is equal to, and we open a bracket and we list the x values typically in order from least to greatest, which is actually how it was laid out for us in the question. So -2 followed by +3 followed by +4. Close the bracket. And the last piece was to do the same thing, but this time for the range. I'm going to open a bracket and list my y values from my ordered pairs in order from least to greatest. -1 followed by 3. And then there is another 3, but it's not necessary to write the same number twice, because the fact that we have already written 3 within the set shows us that 3 is part of the range. It's not necessary to repeat the number. Close the bracket. Okay, the last part of the lesson is actually analyzing those relations that we were just representing. So the graphs of relations essentially are made up of two variables, a variable that is known as the independent variable and one that is known as the dependent variable. These are very important words, and it's important to be able to differentiate between the two. The definitions that we have here is that the independent variable is the variable that is subject to choice, and the dependent variable, as the name would suggest, it depends upon the independent variable. As we go through a couple of examples, hopefully the meaning of those words will become a little more clear. So here's one example. The graph below represents the height of a football after it has been kicked downfield. Identify the independent and the dependent variable for this particular relation, and then describe what happens in the graph. The paragraph below does a pretty good job of doing that, so we're just going to have a look at this one together. The independent variable in this relation is time. It is independent of everything else. It's just going to continue no matter what happens. The dependent variable is, of course, the height. The football, as you can see, starts on the ground or at zero when it is kicked. It gains altitude until it reaches its maximum height. And then, of course, as it loses altitude, it will fall back to the floor. So just a reminder that our independent variable is time. It's going to keep going no matter what, no matter how high we kick, how hard we kick. Dependent, though, what's dependent on the independent variable is the height. Another example here of independent and dependent. The graph below represents the price of stock over time. Identify the independent and dependent variable once again and describe what's actually happening in the graph. The independent variable again is time, because once again that is not affected by anything. Your stock, what happens to your stock does not influence time. But the dependent variable is price of your stock, because that is going to change as time goes on. And if I were to describe what was happening in this graph, I would say that the price increases steadily. Notice how it doesn't start at zero. Possibly you started with an amount of money in your account and then you began investing. So it doesn't start at zero this time. The price increases steadily over time. It does fall. It then increases again, and then it falls again. Very simple description of what we're seeing happening over time. Okay, now it's our turn to have a chance with the 3 exercises below. Now this requires quite a lot of writing. So at this stage, I would recommend that you pause this video, have a look at these 3 graphs in your own time, and see if you can identify what's independent, what's dependent, and then can you describe what is happening in each graph using the words time and speed, or time and dollars in my bank account, whatever words are on the axes in the diagram. So pause the video, try and do your own notes at this stage, and then come back and play the video, and you will see that I have put the answers in for you and you can check your work. Remember, find the independent and the dependent, and then describe what's happening in the graph, similar to the examples at the top of the page. Okay, to wrap up, let's see how you did. I have now pasted the answers in here because this is quite a long exercise for me to write out and not run out of time on the video. So if you, hopefully you did okay. When you have a look at my answers, let's see how they correspond to yours. Okay, so the car traveling to the grocery store. The independent variable, once again, is time. Time's going to continue no matter how fast you go or how slow you go on your trip to the grocery store. The dependent variable, that what will depend on time, is your speed. The car starts from a standstill, and I know that because it starts at the origin. It then accelerates, it speeds up. Then for a while, the graph goes flat, so it travels at a constant speed for a while and then slows down and stops, comes back to zero. That's a pretty steep line, so somebody's slamming on the brakes there. Our second graph is an amount of dollars in an account over time. Once again, time is independent. What's dependent is the balance, the amount of money you have in the account. You'll notice again that the graph does not start at zero. This person already had money in their account to begin with. Perhaps they received an inheritance or were given some money to open their bank account. If I describe what's happening in this graph, some deposits were made. So the graph increases, stayed the same for a while, then another deposit was made, and then obviously a withdrawal until the account was once again empty. And then last but not least, the final graph represents a baseball after it's been hit. So I'm just going to pull the page down. Again, the independent variable is time. Dependent this time is height. So look at the graph. Notice how it doesn't start at zero. The baseball is hit from the height of the bat. It reaches its maximum height, flies through the air, and then finally hits the ground. So mark yourself according to how you think you did, and now begin the assignment that goes with this lesson.